Hey programmers, welcome back to the JavaScript for Beginners series. I hope you learned a ton in the first chunk of the course, and this will actually be the beginning of the second chunk of this course. So you learned a lot, but there is still much to learn. I think to get going on this second semester or whatever of the course, what we'll do is just go over some problems that really kind of encapsulate the first chunk of the course. So what I want you to do is pause this video, go down to the link in the description, work through these problems on your own, and if you get stuck, I'm going to have a walkthrough starting in 3, 2, 1, and let's do it. All right, so it looks like over here, what I want to just do is create a nice file for me to work in. I'm going to create this removedupes.js file, and I'll go ahead and work through this very first prompt. All right, so looking at this first problem, removedupes, what I want to do is write a function that takes in an array as an argument, and it should return a new array where each element only appears a single time. So for example, if I'm given this input array, notice that I have y appearing twice as well as x appearing twice. In the output array, they should all only appear once. And that goes true for any types of values that I may have. So let's jump into this one. I'll start by defining my function. So I'll say removedupes. And it's going to be a function that expects an array of some arguments. And I'll start by thinking about what I want to return here, which is going to be of the array type. So I'll go ahead and start by creating an array. So I'll say let. And I'll say maybe my unique element, so uniques equals an empty array. I'm going to return that array of unique elements at the end, but for now, what I need to do is actually throw some elements inside that array before I return it. So how should I populate that uniques array? Well, I know that my new elements have to really come from my original elements. So maybe I'll start by just iterating through the original array using, let's say, a classic for loop. So stuff we've seen a lot of in the first section of the course. So I'll say let I equals 0. Iterate while I is less than array.length, and then do I++. Cool. And maybe just for clarity, I'll go ahead and create a variable for the element I'm grabbing. So I'll say let Ellie equals array at index I. All right, so now that I have this element, let's just say I took that element and I just threw it or pushed it into the uniques array. I know that would have the effect of really just copying the contents of array into my uniques array. So let's go ahead and do that as a nice baseline. So I'll say uniques.push Ellie. And obviously, if I ran, let's say, just the first example, this wouldn't be the complete solution. Let me try to run this. Let me go ahead and bring my terminal to inside of this working directory I have. Then I can run my removedupes. So this baseline code has the effect of just really copying over the elements of the original array into my new array, but this is actually almost the entire solution. What I need to do now is just limit when this line 9 actually executes, right? I don't want to push the element into the uniques array always. I only want to push it into the uniques array if it's not already inside that array. So I could just use some conditional logic here, right? So let me just say, hey, if the uniques array includes the Ellie, actually I want to say the opposite of that, right? So if the uniques array does not include the element, then I can go ahead and push that element into the uniques array, right? Notice that when this statement is false, that is when the element is already inside the uniques array, then I won't be pushing the element inside of it again, right? That way I don't end up with duplicates. So let me go ahead and run this code. And there we have it. Just to be sure, let's go ahead and run all of the examples over here. Nice. Recall that the array includes method returns a Boolean, so I can totally negate it with just the not operation. So let's keep it rolling. Now let's work on the next problem here, remove vowels. So in this problem, what they asked us to do is write a function that takes in a string as an argument. What our function should do is return a version of the string where all vowels are removed. And vowels would be the letters A, E, I, O, U. So this problem seems straightforward enough. Let's go ahead and jump right in. So I'll define my function, taking in some string argument. And I know that I want to return a new string in my output, so let me go ahead and set that up. So I'll say let, and I'll say new string equals an empty string. By the end, I'm going to return that new string. But for now, I need to make sure I concatenate the correct characters to that return string, right? Spell this correctly. And so let's start by iterating through characters of the original string using a nothing fancy for loop. Let me go ahead and save the current character I'm iterating through as its own variable. So I'll say let char equals my new string, or rather my original string at index I. And if I just took that character and concatenated to my new string, again, that would just have the effect of really just copying over the original string into a different variable, which isn't what they asked for, but I think it's a great baseline solution. So let me try running this code so far. So obviously I'm just copying every character of my input string to my output string, but now I just want to avoid concatenating the characters that are vowels, right? So I just need to work in some conditional logic, right? So maybe just for some clarity, I'll create a nice string of vowels. So I say let vowels equals a string of A, E, I, O, U. And what I can do is use this vowel string as sort of like a reference string to denote whether or not my character that I'm iterating through is a vowel, right? So I'll go ahead and check, hey, if my current character is a member of the vowel string, so I'll say vowels.includes this char. And if that's not the case, then I can go ahead and add that character, which is a non-vowel, to my new string. And so if I interpret this entire conditional, what it's saying is, if my character is not a vowel, then I can go ahead and add that non-vowel to my new string. And only after I'm done iterating through every character of the original string and potentially concatenating them to my new string, should I finally return my new string, right? So let's go ahead and run all this code. Nice, and there we have it. All right, let's get to this spam problem now. So this problem has us take in some very interesting data. What we should do is write a function that takes in a 2D array as an argument, and it looks like the input array contains pairs as elements, right? So that's why it's a two-dimensional array. And it looks like no matter what, in a single pair or a single subarray, the first element is going to be a string, and the second element of that pair is going to be a number. What my function should do is return a string containing the words repeated the specified number of times. So if I look at the first example, I have two pairs, right? I have hi3 and by2. And when I call my spam function passing in that array, notice that it repeats hi 3 times and then by twice. And notice the relative order of things over here. Since the hi pair came first in the array, obviously those 3 highs should show up before the bys. The second example is very similar in behavior. It's sort of saying that I should say cat once, dog twice, and bird 4 times in that relative order, right? Let's go ahead and jump into this one. So I'll define my spam function, taking in an array. I'll call it pairs maybe. So let me begin by just writing a for loop that will iterate through every pair, right? So let me go ahead and do that, the classic for loop. Now that I'm iterating through every pair or every subarray, let me go ahead and actually save it into its own variable. So I'll say let pair singular equal pairs at index I. I think this is going to be pretty useful because I actually want to refer to individual elements of this inner array. I know no matter what that every pair or every subarray over here has exactly 2 elements. And if I reference the first element or the element at index 0, that would be like my word. So I'll say let word equals that. And then if I reference the second element of that pair, that is the element at index 1, that would just be like the number of times that I should repeat that word. Right, it's really important that I have the correct variable names over here, right? I iterate through the pairs array, right? This entire thing is the pairs array. When I is 0, my pair will be this subarray. So that means word is hi, and that also means that num is 3. And now that I have these ingredients, what I want to do is construct my output string, right? So I basically want to repeat my word num number of times. And I know that this number is going to be variable, right? Sometimes it's 3, sometimes it's 2. It could be any arbitrary number. So what I think I'll do here is actually nest another loop to just iterate exactly num number of times. So I'm going to use nested loops here. So that means I should be sure to use a distinct counter. I'll just use j. So I'll say let j equal 0, iterate while j is less than num, and of course do j++. And this inner for loop that I'm writing right now is strictly for the sake of iterating exactly num number of times. So for example, let's say that my num is 3. I know that this inner for loop will iterate exactly 3 times because how will j change? It's going to be 0, 1, and then 2. That's 3 total iterations, right? And at this point, what I want to do is refer to my word. I think the good game plan here would actually be to create an array on the outside. So I'll call it my, maybe just let words equals an empty array. And for every iteration of my inner loop, I'll take the current word from the pair and I'll just push it into the words array. Notice here that I'll be pushing the word the specified number of times. And then finally at the very end, I know that I'm going to have an array containing all of the words, but it looks like they wanted me to return a string. I just need to put a space in between everything. So that's as simple as returning words.join on a space. Let's go ahead and run these examples. Nice, and there we have it. I think this problem is a great review of nested loops and 2D arrays that we went over in the last course, right? So if you're still feeling iffy about this general pattern, what I want you to do is definitely go back to the previous course, right? And work through that lesson once again. But in any case, for now, what I'll do is go on to the next one. Now let's work on this remove first vowel problem. So in this function, what I want to do is take in some string as an argument and return that same string, but with only its first vowel removed, right? So if I look at the input string of volcano, when I pass it into my function, notice that the very first O should be removed, right? In the same way, I removed the first E in celery or the U in juice. This problem is pretty interesting because it has us not only target specific vowels, but like the first instance of any particular vowel, right? So we're definitely going to use some like vowel finding logic like we did earlier in the course, but we'll need to work on this kind of new pattern over here. So let's jump right in. I'll define my remove first vowel function, and we'll take in that string. And let me start by writing a for loop that just iterates through the characters of my original string, right? So this is just reviewed for now. Now that I'm iterating through every character of this string, what I want to do is check what that character is, right? So let me have a nice vowel string to reference, very similar to the previous problem I did of remove vowels, right? So let's say let vowels equals a string of A, E, I, O, U, just to reference. That means I can use like includes or really index of on this vowel string to check, hey, is my character a vowel, right? So I'll go ahead and check, hey, if my vowels reference string includes the character, then that's potentially something that I should remove, right? Because if I enter this if statement, that basically entails that my character is a vowel, right? And I'll have to think about how this if statement interacts with my total for loop. So I know that my for loop iterates through characters in order from left to right. So in other words, when my string is volcano, on the first iteration, char is V. On the second iteration, char is O. On the third, char is L, right? So this has the effect of moving left to right. And I know that the first time this if statement is true, logically, I must have just found the first vowel sequentially in the string, right? So if I enter this if statement for the very first time, that basically means I found the first vowel, right? And so what I can do actually at this point is use that as my return line. So maybe what I want to do here is return early out of this for loop. And what I should do is return my string, but I need to like manipulate my string by slicing some characters out of it, right? So let's say that I'm iterating through my characters and I find a vowel. What I can do is slice the string and exclude this position, exclude this vowel that I just found. I know that the vowel I just found must exist at index I, right? So what I can say is return my string by slicing it from the first character, so index 0, all the way up to, but not including I. Recall that slice, when you give it a second argument, it's going to be excluded, right? So I refers to the index of that vowel, so this would give me everything before the vowel. In other words, it'd give me like the V over here. And after that, what I want to do is concatenate everything after the vowel, so I can do plus string.slice of I plus 1. And since I'm only technically giving a first argument into slice over here, this will slice starting at this index all the way through the end, right? Recall what we learned about slice. Let's go ahead and run this code. Nice, and there we have a solution for this problem. Maybe to add some more clarity to this one, let me type an example for myself. So let's say that we had an example like bridge, right? So I know that I should have the effect of removing the I in the string, so I should get BRDGE. And when we iterate using our for loop, we know that once I refers to index 2, because I go 0, 1, 2, that's the first instance where this if statement is true, right? So this condition is true. And what I do is I return my string by slicing from index 0 to index I, so I slice from 0 to 2, but excluding 2, right? Because that's just how slice works. So that gives me BR on this left-hand side. Then of course I slice starting at index 3 as well. And index 3 would represent this D over here. So basically I'm saying BR plus DGE, and that would give me my final output. Another interesting bit is what happens if we pass in a string that does not contain any vowels? Should have an expectation for this just for fun. So if try contains no vowels, when I remove the first vowel of it, then it shouldn't actually change. Let's just say for argument's sake. Right now, this function would actually return undefined, right, for this new example that I kind of typed out. And that's because at no point in time will this if statement ever be true. And so I finish this entire for loop without returning anything. And technically, I hit the end of my function. I never hit a return line. And so this function returns undefined by default, right? Recall what we learned earlier in the course. So if you wanted to kind of satisfy these examples where, let's say, the input string does not contain any vowels, maybe you just want to return the original string. I know it wasn't part of the original problem statement, but maybe sometimes in your programming career you want to satisfy some default behavior like this. I'm just showing you some options over here. Let's bring all these examples in, do a final pass, and there we have it. All right, let's work on the last problem here, shorten long words. All right, so in this problem, what I want to do is write a function that takes in a sentence string as an argument, and it should return the same sentence string except where words longer than 4 characters have all of their vowels removed, right? So looking at the first example, let's say that this is my input sentence. Notice that words that are long, like noble and people, have all of their vowels removed, right? Because they had more than 4 characters in their original form. So I need to target very specific words in my input string based on the length that they have. And this should really remind you of an earlier problem from this set, and that would be the remove vowels problem, right? My remove vowels problem basically did the subtask of taking in one word and removing all of its vowels. But in this problem, what they're saying is we want you to now target very specific words. So I'm probably going to use a lot of the logic from my previous problem. So let's start by tackling this one. And this will actually lead us into our next topic of the course. It's a nice introduction. And what it's about is really taking a larger problem and decomposing it into smaller subproblems and hopefully some problems that you've actually solved previously. And so let's define short and long words. It's going to take in a sentence string. And I'll start by thinking about how I should consume my input. So sentence contains multiple words. In the long run, I need to have the effect of targeting individual words, right? So let me split this sentence on a space, right? So that gives me an array of its composing words. So I'll say let words equals that. And now from here, that means I can iterate over every individual word using a classic for loop, right? So I equals 0, go up to the length of the words array, and I++. And as we're iterating, what I should do is really check the length of this word, right? So I'll go ahead and check, hey, if the word is long, so I'll say if words at index I, if that has a length that is greater than 4, then I should remove its vowels, right? And I know that otherwise I should not remove its vowels. So maybe just annotate this up a little bit. So if it's a long word, then remove its vowels. Otherwise, leave it the same. Cool. And so inside of this if statement body, I basically need to write all of the logic of removing vowels, which in itself is a pretty complex pattern, right? What I could do is kind of take all of this code and work it into this if statement and kind of find a way to combine the two. But what I could also do is really just declare this as its own separate function and just reuse it, right? A function can be used in really any circumstance that you want. So I'll define my helper function above. Instead of just writing all of the code again, I can just utilize this helper function, right? I already tested this individual code and I know what it does, right? So if I were to, let's say, call remove vowels on the word that is too long, that is words at index I, that should give me my shortened word. So maybe I'll say over here, let no vowels. So that's like the word without any of its vowels. And I think over here, what I want to do, what I should have done is probably taken this words at index I and kind of abstracted it into its own variable. So I'll say word over here. And previously, I probably should have said let word equal that words at index I. It just makes things a little cleaner. Now it's very evident to me that on line 23, I pass in a plain old string variable into my remove vowels. And I know what it does, right? It gives back basically that same string without any vowels. Cool. And now what I want to do is take that no vowels version of the word and put it in some output array that can contain my result. So I'll say let new words equals a new array. It'll be empty at the start, and as I hit this if else statement, I'll take my no vowels word and just push it into my new words array. Cool. So this gives me a complete clause for how I should handle words that have a length longer than 4. And now I want to do similar logic for words that are not longer than 4. And that just means leave the words the same. So I can just take the original word and just push it into my new words array. So I'll take the original word. So nothing much to do in this else statement, but you do want to add that word into your new words array. That way, at least the regular word makes its way into the final output. So that means by the end of this for loop, I have an array containing all of my words where some of them have their vowels removed. I just want to join them up into an original sentence, right? So all I'll say is return new words dot join on a space. Notice that individually, if I just look at the code of short and long words, it's pretty straightforward, right? Because I have actually split up all of this logic into two separate functions, utilizing my previous code from before, right? And this actually makes my code pretty readable. Let's go ahead and run this code, see how it works. So I'll do node short and long words. Nice, so I abbreviated noble and people, and these other words over here like stick and ballerina. It's totally okay if you found this last short and long words problem pretty difficult, because it does utilize a kind of new pattern for us where we take a large problem and decompose it into smaller subproblems that we can, much better tackle individually. And we'll go over this concept in depth in the next video. As always, what I want you to do before you hop into the next video is make sure you have this set of problems down pat. So rewatch the walkthrough if you have to, repeat the exercise if you need to, and I'll see you in the next one.